Welcome. I'm Bill Wig. We're here working on a kaleidoscope, and at the end of the day yesterday, we got the kaleidoscope actually viewing the way we wanted to view it. So this one's set up with 36 sides. This was one with I think 6, and it's gotten there. Now, one of the things we did was we played a little bit with this thing of where in the image are you working, and we talked about putting in something to make that adjustable so it looks like you're working an old kaleidoscope where the image shifts and rotates and so on. I'd like to be able to rotate. I'd like to be able to move. I'd like to be able to scale. I'd like things to stay in the region of what they're doing, or I don't know. And I think that will make a cool demo anyway. Now, I've still got angst about this. We built something that makes a piece of pie, which is a good thing. And Mudshark had the notion that, if we made sure the pie started in the center and then reverse it from there, it looks all right. That'd be a good way to capture it and reverse it, because we can scale x-1 to reverse it. Now, I think one thing we do is, because the y-axis is on the top instead of the, it starts here, so 0 up to max y, instead of normal mathematics where this is the x-axis starting 0 here and y-axis starting 0 here, and so all my mathematical intuition about rotating and placing and 0 degrees and where's 90 and all that stuff is all messed up because of what I think is an odd, unnecessary choice. I mean, I could have seen an argument for putting it 0, 0 right in the middle and having access to everything. It would have been okay. I can tolerate working in quadrant 1, but man, an upside down quadrant 1 just throws me. But we've done these transformations. So this scale Y made it so we could think about 0 being down here, and then we flip it. Well, it flips it up into the negative coordinates way up above the phone. Okay, because it's still positive in any of these, and then we translate it to slide it back down into position where it would have been. Okay, and definitely, my mathematical mind is like, that's not necessary. We should just do the right points. So that's on my mind too. So let me add that to the to-do. Maybe we'll do the rotation or moving first. Adjust pi calculations to avoid affine transformations. Okay. And I think I just have to kind of bite the bullet and figure it out, which is fine. All right. Now movement, we put something in already, this notion of x offset and y offset. So they tell you from the original picture, let's get that out here. Assets. Yeah. Well, I don't know if I can. All right, we'll do it this way. Hopefully. Where is it going to put it? Preview. Well, sorry, I don't see it in any window. Well, okay. At any rate, we've got this picture. We said place it in the frame stretched out so it just fits the whole picture. And then by default, we can start at the center of the picture, which is like right next to this bit of corn here. By doing the X offset, Y offset, we've shifted it over to, I think these are little cherry tomatoes, maybe radishes, but I think they're tomatoes. And we get a different view because of where it shows up. All right. Let's well, I'm running tests. I don't have any tests yet. I don't know if I will or not. I mean, these things, this is the only one that feels mathematical or very mathematical. And it's, I don't know. I'm not sure I have a good way to test it. All right. But we can run. Just want to get checked in before we get going. Okay, yeah, there's our 36 offset a little bit. All right. So we'll commit that, stage all. Tweak the offset. All right. So I looked up this dragging. Yeah, here we go. So this lets us, we can define a state for a location because it's variable, and we can create a drag gesture. And then we've got to listen to onChanged. Okay. And then once you have that, you can put it in the view on gesture on the thing. I don't know if that's, we'll have to see. All right. So, whoops. So first thing is state, and let's just get this location instead of this. So we'll make X offset, Y offset, use these. Okay, so let's take out X offset. I should get a complaint here somewhere. And we'll use location dot X. Actually, that makes me wonder if offset will just take a location. CG size. This is a CG point. Okay, we'll keep on this path. Okay, let's preview. Should look no different. And then we need that drag gesture with an onChanged doing something. Okay. And then we need to attach it. Now, I don't know how this is going to work. And we're going to put this on there. All right. Well, I don't think I need to worry about the finger drag so much. It's really this. Where this goes, well, image demo. I don't know if I can go on this. What'll happen? All right. Oh, no, I don't know what I've done to. I mean, this, we're talking. But I got to adjust these positions because, okay, I don't know, I'm way out here. Now that looks like corn. I don't know how I get to tomatoes. Yeah, the quadrant is. I think the only red is in the tomatoes. That blue is on the far left. And now we're getting off here. Oh yeah, this is very, very visually stimulating. Yeah, I'm kind of tracing the shape up to halfway. Oh yeah, I like it. Okay. Well, I think. Yeah, I think that dragging down here is just the picture's not anywhere to be found. And I don't know if. Okay, let's reduce the number of sides again. I think I can make sure I understand the picture a little better with that. But it looks like I'm going to have to multiply something by 2 to get. I mean, it only seems to be effective. Okay, that looks like corn. Corn. Maybe our limes. I don't know. Tomatoes coming in. Oh, interesting. Okay. And then nothing. And then down. I mean, if this thing is centered, the center point is here. I think I'm getting the picture. But I think I can only go to halfway across on X. Okay, so can I do this? No. Okay. How about CG point X? X is value to location times 2. I don't know if I'm dividing or multiplying. Okay, my value location I think is divided by 2. And we'll just keep Y the same for now. Okay, cannot convert. CG points are ints? Oh, I lost my. Sorry. The location of value or a point? Well, these are doubles. Okay, I must need to do this. Is location of value or a point? It's I assume value is a CG point? I don't know. Right. CG point. So expect to type double. Oh. Dot X. Dot Y. Okay. Now I should be able to see it. Whoops. It goes drag gesture dot value. It's probably something parameterized. Well, I'm assuming that's CG point because that seems to be everything that's location of the current event. Okay. All right. So now, if dividing was the right thing to do, I can drag all the way to the right instead of only halfway. Okay. Oh. Yeah, it's just a little... I think it's the padding is killing me. Although that's not unbearable. And it's a little backwards because that's the leftmost thing on that picture. If I could bring the picture up. Yes, that's... Yeah, so the very left is shown up there. And then over here is the very right. So something's a little backwards. I suspect it may be the process, the way we did our pie was doing it. But that's hard to know. Okay, now let's go the other way. Oops. Okay. If I go down, I don't know if I can tell what I'm getting to. That must be tomatoes towards the top. I think that's that little bit up there. Okay, so, I mean, halfway down to the screen, I don't know. That looks like a third of the way down. Halfway's in the center of this, right here. We're practically gone. And notice the center's shifting. Maybe not. I think the center's staying the same, but the dragging it even this far down. I don't know how we can tell. Well, let's divide it by 4 and see what we get. I don't know that that's mathematically justified. I think it's just probably a combination of the picture size and who knows. All right. Okay, so if I do here, I can feel it slower. Yeah, at the very bottom, it's starting to distort a little. But I can live with that. Yeah, same thing here. Interesting. Okay. Are negative positions valid? Well, valid in... I don't think you get them, like, once I go outside. I mean, clearly, well, I'm working a phone here, so I can't really drag outside the surface of it. I don't think the image is outside the view at all. It's always... see, what we're getting is squashing. Like, I think our touch is maybe getting outside down here. And remember, everything is... Well, no. What is that? I think I think we've positioned our finger on the picture in a way that we're still on the picture, but if you took the circle around it, you'd have some white space, and I think that's what's going on here. Let me. Can I color this? Body. Let's get the last project up here, or 2 projects back. Over recent. Oh, I did not tune sim. Close the whole thing? No. Oh, documentation. I can close that too. Okay. This guy. We put the background view somewhere. Preferred. I guess we put it on each view. Background. That's on the list. I want to see if that white space around it is white or is it gray. Yeah, I'm definitely confused. I'm not getting far enough to. Oh, it is. There, it's gray. Okay. Is there image data above the pie? See, what I'm confused is it feels like the natural XY coordinates. I think it's like the image is right here above it, and we're doing that. I mean, I'm puzzled. Yeah, I spent a lot of time puzzled. Okay. Yeah, I mean, I thought the drag. Well, the thing is, we've attached it to the kaleidoscope view, so that seems weird to me because I would have thought the kaleidoscope view was the circle, and that dragging inside there. I mean, that definitely gives me something. Maybe I'm mixing up how we did things, but didn't we? I mean, we used to have a Z stack. Okay, here's a Z stack. Mirrored view. Like somewhere is our image, right? I mean, where is that? That's that one. Content view. Image. Okay, yeah, so the image resizable. Like, where's that image going, right? I mean, image resizable says take my image and stretch it out all over the place, across the whole view. And then we're pulling, we're chopping out a piece from it. There's a way to get 2 dots. Yeah. So that should be my rotate. Maybe we should look at that. I almost think the rotate should pick a different position in the image. But yeah, now I'm confused about the white space. Touch the image instead. Yeah, I don't think the image exists. Or is visible, I should say. I think we take the image and we've chopped out some stuff with our pi. No, it's not the pi that does it. Maybe it's this thing. Well, we've stacked the two together. I don't like this either. I mean, this... Let's see. Okay, kaleidoscope view. That's fine there. Okay, so he's taking our content and clipping it. I guess that's what we see mirrored. So, I mean, I don't really care if you can move in the image. I want this though. This, like you say, very trippy kind of thing. Because that's sort of what a kaleidoscope does. As you rotate the barrel, you get these, the sense of these things just kind of flipping in and out. And I mean, it's very, I don't know, there's something compelling about it, I guess. That's too much. See, that's the border there, and I go out of it right there. I think that's because I'm outside the view of this, which apparently is this whole thing, because I can drag anywhere in it. So obviously this thinks it owns the screen except for the padding. Okay. Now what it means to rotate. That's an interesting one. I'm almost wondering if I could treat the rotation angle like a spiral and use that point to pick up a 2D point or something. Because what I really want is I want to be holding my phone and go like that and get these views, Excuse me. Yeah, I'm just not sure where to go with it. Also, at some point, I'd like to add some sound, but I don't know. All right. So what would be okay? I think we've done the drag gesture. I call this motion. Okay. And then I'll say add a drag gesture that relocates the point of interest. Okay, and that's cool. Yeah, I wonder if I can... It's very tricky to map. How do I map a one-dimensional drag? I'm sorry, I'm jumping ahead to rotation. So if you put, let's see, control click, yeah. So I can do a rotation gesture in the simulator, but as I rotate, I want I want the point of interest to change. I mean, in a real kaleidoscope, you've got a bunch of little colored beads or whatever in there, and as you rotate, they fall, and so it's more of um, a dynamic thing because of that. And in ours, um, you don't have that same notion. We're trying to pick a different spot on a static image. Now, one one other another way I was thinking about it was like, what if you took, I don't know what the AI, the image stuff can do, but like if I could somehow identify all the little pieces, and it doesn't even have to be the actual things, but you know, maybe the light part of the corn, the dark part of the corn, individual tomatoes, I don't know, the blue stuff, the white stuff. If it could take a picture and break it up into those pieces, even if they're not realistic, but then do the simulate the falling of those pieces around. I don't have to match exactly to the photo because it's not what we care about. I mean, knowing that this is ears of corn, you can kind of believe it when you see this part of the spiral. Maybe that's the lettuce, and like somehow that's the tomato. Um, you can sort of relate it, and that's fine. Yeah, when I drag off, it's kind of cool that you can relate those pieces, but it's not critical to the way of this. Man, it's easy to see faces and things, isn't it? um, so if I did something like break it up into pieces and rotate them with a little bit of a sort of like oil viscosity and a little bit extra less gravity or something, where they would mix up and spin around as you tilted, I mean, that would be kind of cool. That's kind of what I wanted to do with the 3D stuff. But if I could do it off the real thing, that's all right. Um, Now, I guess you could define your angle like an angle. You got 0 to 360, so you could kind of divide the grid up into 360 pieces, right? And um, select one of those grid pieces as a center, um, just to get a translation. All right. So I don't have a formal. Whoops. Um, I don't have a formal plan, really. Surprisingly, right? I do want to come back to this. Yeah, maybe there's some. I mean, I think that would give it something. Yeah, I I don't know. We'll have to let that stew, I think. Um, but I think the next gesture would be rotate gesture, which kind of maybe a scale gesture too. I don't know. Maybe I should try and do that. Um, yeah. So I forget what I searched for, but if I just swap in rotate instead of move. Okay. So rotate gesture. I mean, this is, yeah. Well, let's add this. And I don't even know if I have to keep simple drag. I assume this is angle equals dot zero. Okay. And then Well, that can be on one line. Okay, this should run because I'm not doing anything with that gesture. Okay, and that's fine. Just to make sure I understand it. Yeah, so, okay, well, it's in radians, but minus 2.3 to 3.89 radians. Well, 2 pi, right? 2 pi radians is 6 point something. I guess if you divided it, no, I don't know. Maybe they're detecting forward and backward rotation. Okay. Can I convert this to degrees? Yeah, like map the rotation. Yeah, figure 8 or something. Okay, minus 20. And now I've switched to... Okay, there's 300. Interesting, sometimes they're negative and sometimes they're positive. I don't know what the difference is, but I'm not seeing anything bigger than 360. I started there, right? Oops. Okay. So let's try and image. Let's see if we can rotate our thing. Effect. Angle. So I expect the whole kaleidoscope to turn. I'm not saying that's where we want to go, but it'll give us proof that we're actually working with this thing. Oh, yeah. Okay. And that feels very direct. I guess because it's in motion, I'm seeing that extra stripe. Yeah. Okay. Right. I don't want rotation to be that. I'm wondering if I Right. So this notion of map the rotation degrees to a figure 8. Yeah, like I want 0 to be grab the absolute center of that image, right? I want that to be 0, 0. The problem is, well, I don't know if I'm getting scale. So when I do this rotation, oops, yeah. Like when I drag them further apart, if I do that on an image editor, the picture gets bigger as well as rotates, So I think we're going to add the scale as another gesture. Let's call this move focus. All right. And then is there a scale gesture? Drag magnify gesture. Okay. Let's put this in too. Whoops. Oh, gesture state instead of state is probably right. No, is that CG size? I don't know if this will work. Notification. No, let's go the other way. 1.0. Okay, that's a double. This needs to be a CG size. I don't know if it'll take a double. From width height. Well, that's not very helpful. Oh, it takes that. Okay, scale effect. Scale effect magnify by, gesture state far magnify by. Oh, gotta use the same name. Okay. All right, so this we expect to rotate and scale our picture. Okay, so rotate. Oh, scale is not doing it. Is that because I started off by rotating? Okay, let's... Well, let's just print value. And I'm going to turn this one off. I wonder if they conflict. I don't seem to be triggering my magnify gesture. Oh, move focus, rotation. Rotation's the one I'm worried about. Maybe this doesn't... All right, so... All right, let's try again. I mean, we're getting nothing. And we're not even triggering it. So, did I put it in? I've got gesture. Oh. Wow. Whoops. Scale effect magnified by. Oh, I never added the stupid gesture. Okay. Vacation. All right. Okay. When I let go, it goes back. Yeah, I mean that's okay. Now I don't know if I can use this. What's the maximum? When I hit the edges, it bangs back. Okay. Now I don't really want to do this. I just want to see what the scale I'm getting is. Value magnification 0.0055. Magnification 3. Magnification 4. Is that because I... Yeah. Okay, and then we'll see if these are regarded as conflicting or not. Well, they're not regarded as conflicting, but this one just wins. Okay, well, the natural thing to me... Well, at last we have something I'm going to need to test. What I want... Okay, I'm going to take off this padding just to see if that theory makes a difference. I'm not getting both magnify and rotation at the same time, though. Okay, yeah, now I can't get to that bad point. Yeah, I think that's another kind of safe area thing. So I don't get the gestures at the same time. So that means I got to choose, do I want the magnification or the rotation to matter? Well, I think rotation is more likely to make to feel natural. And on this, let's take the magnification off. Actually, I think it doesn't matter because that's the one that's not. Rotation. When I let go, it stays rotated. Whoops. I was worrying about move focus. It stays where I leave it. Okay. Okay, so I don't know. What I'm thinking is like somehow 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way around. So the distance to the whole circle so 0. Well, 1, 2, 3, 4, 5, 6. I'm wondering if I treat it like concentric rings, and I imagine 6 concentric rings. Oh no, that's still not going to be... Interesting. I want 0 to be here, so no rotation. I want it to be centered on the middle of the image. If they rotate, the more they rotate up to here, yeah, the thing is I can't see. I don't think rotation gives me the whole thing, but magnification did. So maybe I need magnification, and I'll take out rotation. I don't know. I may be worrying about a lot of stuff that's not going to matter, but so the notion I have is if I do magnification, you see, it's giving me the anchor. I get the magnification factor, velocity. I don't know how to interpret start anchor and start location. And start anchor and start location don't change. But I don't seem to be getting the current location. Okay, so now I'm going to start them again. $196. I don't know. It's always $196. So that's not giving me anything. I'm not getting the move. Okay, let's make sure that's true. Okay, I didn't see any drag twos up here. I don't get them. Okay. So I guess what I want is I want a formula that tells me I want 0 degrees to correspond to this. To the center. Maybe it shouldn't matter. If 0 degrees is the corner, top corner, and 360 degrees is the bottom right corner, top right, bottom right. If I'm well, I could pretty much go straight line there, right? But I'm kind of trying to imagine something like this. Okay, so I guess I'm imagining a function that does small vibrations here and they get bigger and bigger and bigger and then back to small and then to there, and then I'm kind of taking that on the diagonal. Well, let's try and make a picture, I guess. And slide, blink. Okay, so the shape, where's that freehand? I'm imagining something like no, I'm not good enough with the pencil. Double click lines to toggle, drag a midpoint. Okay, so well, I don't see that doing any toggling, but this function, I'm imagining 0 to 360 on the bottom. I guess I can do that. So 0 degrees corresponds here. And then 360. And I'll probably just add a little bit more. I don't know. Does this make sense? um, and so I guess, like, how many ups and downs do you have is interesting. Yeah, it's hard when you're not sure what you want. I mean, I'm sort of imagining this hump going up as one segment, then the valley, then a bigger mountain, bigger valley, up to here, bigger mountain, followed by biggest valley, followed by smaller mountain still. And so, like, how many vibrations do I have in there? Well, I don't know. It's kind of arbitrary. It's and maybe the sloping isn't right. It's like it should be a gentle slope. I don't know. It's just got to do something, I guess, is the deal. I don't know. More to simmer, I think. And I don't know if I can put my shape in. Well, I think I'm imagining something like this. I don't know. Is that going to be the right way to think of it? Maybe. Oops. Maybe not. Maybe this is. No, it's some. It's something more like this. And maybe I gotta rotate this too. I don't know, that doesn't really add anything, does it? Excuse me. Well, I'm thinking something like that is my interpretation. Like, I don't know, you're dragging through. Maybe I can just take, like, 0 to 360 represents the x-axis. And then your distance from the no. Yeah, I think I'm trying to do polar coordinates, kind of, but I don't have. When I get the magnification, I don't get told the current location of the points. I only get told their start location. Now, maybe I could make something where you click in the circle, that I interpret this as I don't know. I could interpret one of the location. Maybe the location of the magnification is corresponds to the location on the picture. I don't know. I mean, what I want is rotation to give me this feeling, and um, I could take the degrees and just kind of work my way along the diagonal of the picture, but that doesn't get me the rest of the picture. So I was imagining if this square is the picture, I was imagining like 0, 5, 10, 15, 50, 60, 70, 180, and so on, working my degrees to cover the whole picture. But when I'm doing this, I don't get drag coordinates. Unfortunately, I don't get both magnify and drag coordinates. Now, I don't know if that's true on the real phone, but definitely here. Okay, so let's try and take I don't know. Yeah, that was the kind of thing I was thinking. I mean, a sine curve or something like that, but it's got to be multiplied, right? Because by the time I get to the center of the sine, I've got to go the whole distance. So it's kind of multiplied by, I don't know, some other kind of mountain curve or something. But maybe that's okay. Yeah, maybe I just have to make it. I don't make it one sine curve, right? I make it the if I did a sine curve top to bottom. Yeah. Okay. Let's take out magnification. Let's try something on that line. And I'm going to take out move focus. All right. So the rotation's the one I want to get, and I get an angle, and like, what if I take the sine of the angle and the cosine of the angle? Is that gets me something? Yeah, well, I mean, I think I can multiply or divide enough to make it do that, right? So if you take sine of 3x, you go faster, right? 3 times as fast. Let's take that into account. So if I take the sine, okay. Let's just work on the regular sine for the moment. Okay. And if I take I guess I need to find out the location. Okay, if I take the sine, I get a number between -1 and +1. And I don't know. It's like I don't have access to the... I'd like to know the coordinates. Right. I mean, this multiplies and divides here kind of got us. Oh yeah, yeah. Maybe cosine's the right one. Is it? Or I always forget the one shifted off from the other. Yeah, 0 to 81 goes one way. 180 to 360 moves back. Yeah, that would be nice. All right. So if I took the cosine of the angle, the magnification angle, I get a number between 0 and 1. And if I take that number as the point on the x-axis, I just want to take the angle on the x-axis and the sine on the y-axis. Okay, so, but I got to get them scaled into some level that makes sense for this. What's that geometry reader thing, right? Geometry. Content. Okay. And now, okay. I think I can make this do something. All right, I'm going to take out scale effect. Actually, I'm going to totally take that one out because I don't think we need magnify. Excuse me. Okay, and so I want location to be changed Let's pause. Okay. Okay. I managed to break this. Okay. Rotate, adjust your move focus. Okay, so that does that thing. Take this print down. And this does the rotate. Okay. Okay, so what I think I want to say is if you, well, I'm going to take this off. I'm not going to rotate anymore. I'm going to try and adjust my offsets. If you rotate, I want angle. Well, I really want okay, so I'm going to get a number between 0 and 2 pi. I guess plus or minus the way they do it. So, maybe I don't need to worry about the negatives yet. All right, but what I want is the offset to be based on the angle. So I want to take geometry dot size. Okay, yeah, that's the thing I want. Okay, so let's write a function. Now we know it could be testing something. So this is map x. Well, let's say x angle to x. And it takes an angle and a size, which I don't know what that is. And it size is geometry dot size, right? It's CG size. Okay, and this returns a CG point is 2 float. So I think it returns a CG float. Okay. And let's return 0 for now. Okay. And then the offset is angle to x for angle and size. Okay, so I'm going to take the rotation angle which is maybe plus or minus 0, I don't know, plus or minus pi, and map that to how much I offset. Okay, I think this will do something. Okay, my drag gestures still do something. But X doesn't matter, only Y matters. Okay, because X always returns 0. Okay, now let's see. So what I'm imagining is you gave me this angle. I'm going to convert it. Radians. Okay. And if I divide by 2 times pi, and all that is size dot width times that. Okay. I don't know if this is going to be the right thing, but it's going to give something. Okay, so on a rotation, all right, I'm getting something. It's not scaled correctly, but okay, that's too far. I mean, this is the kind of feeling I want. But I think what's happening is I'm only looking... I think I'm only going across the midline of the image, the center Y. because the way we do it. But I think what this is telling me is if I were to somehow figure out how to scale this right, oh whoops, rotation, like that's just too far. Okay, but that's kind of what I want. And then the Y. All right, and let's try the Y. Angle to Y. All right, I want to take the angle. Well, I want to take the angle and take the sine of that, but okay, but for starters, maybe. Okay, so the first one, I'm taking the rotation, and I'm using that as the offset from X. Okay, and now I want to take the height, and I'm going to take the sine. So the sine bounces around. Well, it if we just do one sine cycle, my Y is going to go up here, and then over here, and then down here, and then back here. Okay, but they're coordinated, right? So I can't get as much, but I think this will give me something. And then I got to worry about scaling and limiting and so on. Okay. And maybe I should pass the width and height respectively. I don't know. Okay. Maybe the offset could return a point. Okay, let's see what this does. All right, so a rotate. Okay, now I'm going to multiply this. Let's do it 10. And I don't know, I'm going to have to figure out the bounds. I mean, this one should always be bounded 0 to 1% of the height, right? So that should be okay. Okay, I'm definitely getting different stuff. But I've got to do some limiting. Okay. I think that's a start on the idea. I don't think it's perfect. So let's take a break. So 3 or 4 minutes, and we'll come back and refine these. So this one, I'm going to make sure that the angle only has the range 0 to plus or minus pi, something like that. And this one, I think this should be okay. It's 0 to 1. I'm sorry, it's plus 1 to minus 1. Oh, we might have to do some dividing. Yeah, well, we need to do some adjusting, but it's a start. I think it's an idea that we're sort of filling up the screen with sine waves, and so we can get to almost any point somewhere on that position, and then I think tweaking parameters and stuff like that to make it kind of feel naturalish should get us there. And if we can get the bounds right, so we're never grabbing stuff outside the range, kind of like we did up here. All right. See you in 3 or 4 minutes. Welcome back. All right. Let's try and do some adjusting. So I think the first adjustment is this one, location divided by 4 before, and now we've got the total height. So sine of x is always between -1 and +1. And we're doing an offset in the end, right? So this can be kind of negative. So I think I'm going to try divide by 4 just like we did before. Unjustified, but I just want to get things in a range so I can see what's going on. If that makes sense. All right, so here. Yeah, I think these bumps. So I would call this 0 to -30. Okay, that's to -30. 0, 90, 270. I mean, it should come back, right? Yeah. Okay. Why are you messed up? Okay, well, I'm going to try dividing this by 2 as well. And see if we can get something like we had before. Okay, so that's, oh yeah, we're getting there. And we're getting something. We never saw multiple tomatoes before. So we're centered over there somehow. But man, by the time I'm at 90 degrees, -90, I'm messed up. And then 120. All right, so let's work on the ranges. I think it's time to put a test in. It's kind of arbitrary stuff, but this is definitely formula stuff that we can check bounds on and stuff. Okay, so well, let's at least make it a test. What are we going to call this? It's rotation to position tests. We'll find better words. Okay, so the test is values below 2 pi. No, below. So in polar coordinates, right? 0 is, well, over here for you. 0 starts and then wrap it around to pi and then to 2 pi. But you can also go 0 to -pi to 2 pi to -2 pi. So below -pi, wrap around. Okay, so do I need to extract this out? Boy. Well, for now, let view equal content view. And then actually I'm going to test something simpler. Test 0 maps to 0, 0x. We'll probably put these in a better place. Okay, and then if we call view dot angle to x for dot 0, and the size is CG size, width, and height. Well, let's just make it 100, and we don't care about the height. Okay. Okay, I expect x to be 0. Okay, let's start. Let's do this now. Value below negative pi wraps around. Now maybe I should be looking at those rotation values again. All right, we'll take the same deal. Okay, so if you have an angle and it's angle dot degrees, well, radians. Now let's take minus pi minus 1. Okay. Now I'm not sure what that should wrap around to. Well, I guess what I want is I want a number that's between pi and negative pi. And if you give me more negative, I'm going to add to it until. Okay, why aren't you happy? Can't find angle. Okay. All right, and then the answer should be well, we're going to look at x. It's going to be some value with some amount of fuzz because we're dealing with floats. Okay. I think I have to say something there too. Like accuracy or... see if that's right. Okay, so if it's minus pi, then I've gone this way. And then I'm going to add 2 pi to it. Okay, so it's below negative pi. I'm going to add 2 pi to it. that puts it in the range 0 to pi. Okay. And then the x-coordinate, yeah. Well, the x-coordinate's complicated, right? I got to multiply the width times that. So somehow this width times that division, if I don't know, I feel like I'm computing the answer to get the answer, but I got to add 2 pi back in to this thing. So it's really just pi minus that, right? Okay, so if I add 2 pi to this, I get plus pi minus 1. All right, and then I got to multiply this times that, divided by 2 times pi. Now I think that's, well, it's certainly reflecting the computation. I don't know. But I don't have a good way to say what the answer is otherwise. Okay, now this minus 325 is not equal to 336. Okay, well, the problem is if, well, I don't want the 2.0 on there anymore. Okay, I think I'll get a better answer, a better failure. Minus 650 to plus 336. Well, I don't know. Okay. What I want to say is if the radians, if angle dot radians is less than minus pi, let's do working angle equals angle dot radians. Okay. Okay, so if it's too far negative, I'm going to add 2 pi. We're only dealing with one at a time here. Okay, and then in the end, I think I want to do this working angle divided by 2 pi. Okay, so adding it and then dividing it. Oh, and then I got to say return now. Okay, so if my angle is less than minus pi, that means I've wrapped around, and I'm gonna add 2 pi to it, which if it was just barely negative is going to be now positive. Okay. Do I think this is the answer? Yeah. Take the angle divided by 2 pi. That gives you a scale and scales the width by it. Yeah. Okay. Now, I'm going to do this next test. And maybe I could throw away this one when I finish it, but values well below negative pi. wrap around. Okay, so let's make this minus 3 pi. Okay, so if that's sort of an extra wrap, right? So it's wrapping 1 pi plus a little, minus 1 is a little more, and then 1, 2, it should wrap to the same place. Okay, because I've just added 2 pi, or I've just taken 2 more pi away. This one's going to fail, but I think I can turn it into a while loop and make it pass. Okay, and so it didn't go far enough. It was still minus 650. Okay, so if the angle is less than negative pi, we're going to keep wrapping. So it's too negative. It's just too negative. We're going to keep wrapping with 2 pi until we get it into the range of minus pi or higher. All right. And should pass. Okay. Now, so this one just got me started. This one put the if in there, and this one put the while in there. This is actually redundant, but I think it shows how we got there, so I'm going to leave it. But that's, I don't know, that's given us something. All right, and then, so minus pi, I feel like I'm not quite getting the right answer still. Yeah, because oh dear. Okay, so we're doing an offset from the center, and so I want 0 to pi to be offset to the right and 0 to negative pi offset to the left, or vice versa. I don't really care, but I just want to make it off that. So I think this should be minus half of the size dot width as well. Okay, so 0 goes to 0. I think that's wrong. Okay, so I mean, I think we're doing the right thing on the adding pi stuff, but I want degree 0 to be in the center. Okay, so I want this to be 50. Now this test is going to fail because obviously it was 0 a second ago, and we didn't change any of the code side. All right, so I want to take away size dot width minus divided by 2. Okay. So if it came up 0, no, that's still not quite right. Zero degrees should be half of the screen, the width. Okay, so I guess if I take away half the width, so it's 100, well, it's 0. It's like I should be adding half the width. Maybe that's more right. since I got negative pi or positive pi. Okay, so let's try that test again. Let's delete this file. We don't really need it. Now that we got some real tests. Okay, I think this will pass. Okay, now if well, these other two should fail now. So let's take, instead of -1, let's take let's make this minus pi over 2, excuse me. Okay, so pi divided by 2 is 90 degrees, which is a quarter of the way around. So I want this to be equal to, and this is almost better. Let's let target radians equals pi over 2. Okay, and let's use that in here. Target radians. Okay. Really? Why are you angle pi? I don't think it's ambiguous. Why? Well, I don't know. I think angle has pi. I thought it was just a global constant. All right. Angle has no member pi. Well, what is? Copy results. Oh, not math. Oh, double. Okay. Interesting. Alrighty. And type of x is float. Do we have a float up high? Okay. All right, now x should be, I want to say 25. Okay, so we're going, oh, yeah, it's 75. We'll see. Okay, so we're going minus pi minus 90 degrees, pi over 2. Okay, so that puts us at 90 degrees. All right, and at 90 degrees, I think that should be halfway between, that should be the positive value because we add 2 pi to it. And so we'll get up to pi over 2, 0, pi over 2, and that should be halfway across the positive side. Oh, yeah, it would help. Let's see if I'm right first. All right. Is it 25 or something completely random? 296. Now that seems a little far off. So 0 should be 50. Pi should be 100. And pi over 2 should be 75. Now, how did I get 296? 296.7. Okay, so I don't know how I get anything over 100 unless my calculation is more than 2 pi. Okay. Okay, while it's less than negative pi, we add 2 pi to it. That seems like it should get. All right, let's track it. See if we can get this to there. Size dot width. Wait a minute. Size. I passed in a size. Angle is 0. Am I on the right test? Angle should be this. What test am I in? Okay. I think I may not be here yet. Yeah, okay. All right, let's continue. That's more like 100. Okay, so size dot width, what's working angle is 1.57. Well, that looks like half of 3.14, so that's pi over 2. Right? So pi over 2 divided by, oh, it should be 2 times pi. Divided by 2 times pi. Pi should be, well, what the heck? Pi over 2 divided by 2 times pi. Is that 1? That doesn't seem right. Okay, my working angle is pi over 2. Pi over 2 times 2 over pi is 1. That seems wrong. I want that to be a half. Working angle. Oh, he should be over pi. pi. Well, I don't know. Pi over 2 divided by pi is a half. That does seem like a better answer. It's a half plus a half, but that's still not right. Okay. So my tests are not helping me right enough. Maybe I'm starting from too much. Okay. So let's put the borders on, and if I can get those right, that will probably help. All right. So if I get 0 to pi maps to 100, pi maps to max x. Okay, so all right. So if I do angle is angle dot, well, is that 0? Can I say angle dot pi? I think I proved I can't. Okay. Well, if I say degrees 180, I don't know if I'm killing myself with the 2 pi stuff. If I get to 180 degrees, 0 to that, I want this to be 100. Okay, so 0, 180 degrees is wrapped around forward and should represent 100. Okay, let's see how this test does. I think it's going to fail. Move the 2 or make it 4. Well, yeah. Okay, let's continue. Okay. Well, we're just going to continue again. Oh, well, something works. Okay, that's good. I don't know if I can say radians dot pi. Okay, and this test should be unchanged. Okay, and then I want to test that half pi maps to mid x. Okay, so this should be 75. This should be pi divided by 2. All right. So 0 corresponds to the center. Pi over 2, or 90 degrees, corresponds to 3/4 the way across. And then pi, 180 degrees, corresponds to all the way across. Okay. You know, I don't see how this one passes. Because it's sort of like the test we just did over here. It does pass. What if I... Okay. And then the next test values below negative pi, wrap around. Okay. So this is, well, I'm going to make angle radians pi over 2. Okay, so this is the same radians except minus pi. Okay, and that should also equal 75 because instead of wrapping around up from 0 to 90, we're wrapping around through the negative side and around to 90 the other way. And it should still be 90, and so it should be 75. So minus pi, this is negative, below negative pi, so we're going to add 2 pi. So minus pi plus 2 pi is pi, then we still subtract the target radians. Is that right? Minus pi minus the target radians, right? So pi over 2. Pi over gives us pi over 2. Yeah, I don't see why this shouldn't pass just as well. Okay. Maybe that divided by pi over 2. Oh, did I not do this one? I thought this one passed. Okay. I don't know. What's... Xcode's being screwy. Alright, let's just run them all. I mean, trying to get this twiddly stuff right is really hard. I mean, it maybe somebody's got the intuition that just make it plug in and it just works out for them, but that is not me. Some things I can just whip off, but these math ones I just have to work my way through. Okay, why are you not running all my tests? Xcode, you're making me upset. Okay, something should fail. Now this one, I suspect our answer is wrong. So, okay, so this one, 84 is the answer and 336 is the expectation. Well, 84 sounds much more like on its way to 100 than this does. Okay, so I'm gonna use minus 3 pi minus, let's subtract pi over 2 again. Is that what we used here, right? Target radians. Well, let's do the same thing. Okay, so now this should be 75 again. Okay, because minus 3 pi minus the target radians, we're going to add 2 pi, gives us minus pi, so we added 4 pi. And 4 pi plus minus 3 pi is pi, minus target radians gives us back to the 90 degrees. Okay, and I think this will all pass. Yeah, I don't know the algorithm. That's what it comes down to. So I'm kind of, well, of course I'm floundering around to get there, but eventually here I said, okay, let's get some boundaries, right? Let's check 0, check the far end, check the middle, and we're doing better. Okay, now I think we're finally ready to go to the other side of things. What if you came in with 6 pi? Well, 6 pi is too big. If you start dividing by 2 pi, you're going to get 3. Well, we want to map that one around too. So let's check the boundaries on the other side. I think I want this test. So neg pi maps to minimum x. All right. Radians pi. Let's make this minus pi. Okay. CG width, and then this should be 0 with some accuracy. Okay. And this test, I don't know if it'll pass or fail. It should pass. We're in our range still. Okay. But now, let's... value above pi wraps around. And I'll say just above pi. Okay, so in this case, oh, wait. I still need... let's put another test in. I want a test that gets to 25 for the answer. Okay. And so if I do angle radians minus pi divided by 2, negative half pi maps to 1/4 x. Okay. We'll test this one that I hope works already. I think should work already. So we'll cover going around this way, 0 halfway there, going around this way, 0 halfway and there. And now this one is the case of ones that went around in the forward direction but went past 0 and now they're negative, slightly negative. Okay, so value just above pi. Let's take pi plus pi divided by 2. Okay. That's bigger than pi. So it should subtract 2 pi. And then we have minus pi plus pi over 2, which is pi over 2, which we know should be 25. Except this will fail because we don't do any subtracting when it's too big. Okay. And I'll do it the slow way. Let's just start with an if. If it's greater than pi, then we're subtracting. All right, and I expect all these tests to pass, and then we'll add one more test. Good. All right. And this is value well above pi, wraps around. So let's make this one 6 pi. Okay, and it should wrap around to 0, which corresponds to 50. So 6 pi once, twice, 3 times around puts us back at degree 0, which should map to the center of the board. Okay. And this will fail. Okay, and because this should be a while. Okay, so now, well, let's push this. Stage everything. So we added tests to make sure X stays in range of its size. I wonder if there's a way to let that I'd like to close that window when it's done. All right. Okay, so here we are. We got rotation of 0. Okay, I think our Y is... Okay, well, we saw the wraparound. Okay, so here's the center was our starting point, and then 180 around, and I'm coming back around to this side. Okay. And yeah, I don't know if that's the Y that's messing that up. Okay. But we got half of them blank, and then they come back in. Okay. All right. Interesting. Yeah, let's just see if there's a preference for that. Keep my source control. Enable text editing. Show source control. Well, I don't want to care about that right now. Yeah. Get. Refresh local status. Fetch. Yeah, okay. Well, that's too bad. I find having to close this window all the time is kind of annoying. All right. So I think X is good. I'm not going to rotate anymore. I don't think I need this move focus. We're doing something like on our rotation to deal with that. Okay, but I do want to deal with the case. Okay, I'm going to take this out. Make sure we're the same. I need to deal with that sign case now. Okay. Okay. All right. Well, let's look at angle to Y. Okay, so the thing we did... Now, I don't know the width... Let me just peek at size. Because I think our width is going to be right because it's the width of the screen is the width of the thing, but I don't know if the height... Yeah, the height is 759. That's not... Okay. I think we have to work with the width. Oddly. Okay. So all right. Sine. Okay. Yeah. So the height is also wrong. Okay. Yeah. Let's start testing. Okay. So, well, let's make this angle to x tests. And then I don't usually do this, but I'm going to put it in the same class. Same file. Angle to y tests. Okay. 0 maps to, well, that name was wrong there, isn't it? 0 maps to mid x. Okay. All right. 0 maps to, well, sine of 0 is 0. I remember that much. So 0, it should map to mid y. Okay. Well, zero actually maps to mid x is the funny thing. Okay. So angle of 0, height of 100 should map to that. All right, that should clearly fail. Okay. Well, I want I guess I want to know how this passed. Well, 10 times 0 is 0, so sine of 0 is 0, times the height is 200 divided by 4. This 4 is just randomly there and did the job. Okay, so now I should fail, I think. Now, how's that passing when I change the code? It was 4. I don't know. How is it equal to? Oh, gotta start on y. Okay, now we'll get that failure. And once again, many times I've had this surprise where my test passes. And very rare like that, where it passes and then I edit it to something completely different and it still passes. Okay, that's better. All right, 0 is not equal to 50. Yeah, that's kind of what I think. All right, so this, well, one thing is this should be the width, surprisingly, but I think that's what we want. Angle.radians, it's like this one. We have to add the width in. to get it where we want it. Okay, so I think that will be okay. And I'm gonna maps to mid X, yes, X. Okay, because that is surprising because we expect it to map to mid Y. All right. Now, okay, so, well, I'm going to start here. Okay. We'll change this. The next test I want. Okay, so if I have an angle of 0, pi should be 180 over 180 degrees around the thing. Okay, and I think we want, well, the sine, when you get 180 around, right, is back to 0. So pi should map to mid X as well. Okay, so this angled radians pi. Oh, I wrote it the other way before. Let's keep up with that. Okay, so angle dot radians of pi should map there. And so should 2 pi. Okay. Well, let's get this one first. Okay, what are you thinking? Okay. I'm just going to call this fuzz. And let's define it up here. And use that here too. And doing floating point comparisons, I really should be doing this sort of thing. Especially with multiplying by pi. And okay. Excuse me. Yeah, its sine is cyclic, so it goes up and then comes to the center and then back down and then up to the center. So 0, pi, and 2 pi should all, or negative pi, should all come to the same place. So we'll check that here too. Neg pi maps to mid X. Okay, so radians minus pi, and I would hope this would pass. Good. All right. Now this is more dependent. So the code right now just has one sine wave. So if you think about how much coverage do you get of the picture, right? You're not getting much variety across there. But I think if you, I want to put a number in there. Maybe it's like repeats. Okay, so I'm gonna modify this. Let me rename this file. XY test. Okay. Good. I'm gonna add that thing in. Repeats 1. Okay. And here it's repeats is an int. And this is repeats. I'll probably have to cast it. Yep. Whoops. I kind of have a choice there. Okay. I'm going to add one for 0 maps to mid X even with repeats. And I'm going to make it repeats 100. But basically, you're always starting at 0. Sine of 0 is the same as sine of 100 times 0 is 0. And, well, it's sine of 0, which is 0. Okay, so this test should just pass. Okay. And pi, well, I don't know how to make this convey. So the radians of pi is sine of that is 0. Sine of 100 pi is, well, if you take away all those 2 pi's, it's back to the sine of 0. So it's still the same. But can we screw it up? If you take 3 pi's, it's the same as pi. Okay, so yeah, that shouldn't care. All right, but let's make a case that does care. Test half pi maps to Well, so the sine of zero, sine of half pi should be the max. Max x. Yes, x. Okay. Okay. If the repeats are 1, that's a simple sine curve. Well, going this way. Half pi is the max point, and so that should be 100. All right. And then this is pi divided by 2. Whoops. Okay, so this test, I think, should pass. All right, now what's going on? So pi over 2. I would have thought should be 1. Oh, yeah, that's why that's screwing up. So repeats is 1. So this is just angle.radians, which is pi over 2, which is 1, times the width plus the half. I'm screwing something up. Okay, the range of sine is 1 to minus, well, minus 1 to 1, I guess. We want 1 to be should this be a minus size of width? Okay, so sine of 1, golly, should be, is it size of width over 2? So the 1, if it was 0, sine of 0 is 0 times width is 0 plus size width over 2. That's fine. If it's the sine is 1, well, then it should be half. And if the sine is minus 1, it should be 0. Okay, so I think now that may suggest that the other one needs to be worked out too. Like they should be symmetric in some sense, I think. All right, so if I take the sine being 0, I get 0 plus a half a width. All right, that's fine. If I take the sine being 1, I get half a width plus half a width, which is the whole width. And if I get sine minus 1, I get width over 2 minus width over 2 plus width over 2 is 0. All right, so I think this is correct. And then I think the flip side should also be correct. Negative half pi maps to min x. It should be 0. Yikes. All right. And I believe this covers that case too. Okay. Now the question is, why is this one not the same? Because this one's working with x over 2. So I guess I could rewrite that size of width over 2 times sine of this plus 1. Is that, I don't think that conveys anything better. Maybe 1 plus sine is either 2, 1, or 0. That might mean more. Double repeat angle radians. Okay. Because 1 plus the sine is either ranges from, well, the sine ranges from -1 to 1. So 1 plus that ranges from 0 to 2 times half the width ranges from 0 to width. Okay, does that make sure that makes sense? Okay. Now this one, this is also 1 plus that. All right, so that's size dot width. Size dot width over 2 times 2 times working angle divided by 2. I think it's 1 plus working angle divided by pi. I don't know. I'm going to leave that one. All right, but we haven't dealt with the wrapping yet. And that, oh, I see we're out of time. Okay, let's stop here. I'll write the test name, which is test wrap to negative values and a corresponding positive. Okay. We will start there tomorrow. And let's see. So tomorrow, 2 to 4:30 Eastern Time or 6 to 8:30 p.m. UTC. We'll pick up with these last couple of tests to get the corresponding wrapping code in here to get it ranged from -pi to +pi. Although, actually, it doesn't matter. Okay, what we need to test is the repeats. Because sine is perfectly happy with negative, way negative or way positive. Test repeats. Okay, so tomorrow we'll start there. Testing repeats, what happens to make sure we get, if we have 100 sine waves in there. All right. Yeah. Anyway, thanks again. I'll see you tomorrow or some other time, I hope. Bye-bye.